Okay guys, here's your second video on factoring polynomials. Okay, so here in the notes you'll see that we have greatest common factor, difference of squares, sum of cubes, difference of cubes, trinomials, 4 terms, and then just a mixture of factoring. So those are all the different types that we're going to review today. Just doing some kind of quick examples. This is mostly to refresh you, so you should have already gone over these in your previous courses. Okay, so let's look at the greatest common factor first. What you're doing is you're looking at what types of factors each of your terms share, and you're looking for the biggest one, which is greatest common factor. Okay, so let's look at this first example here. Let's look at what kind of factors we have that are in both of these numbers, 24 and 54. It looks like our greatest common factor would be 6. So we'll factor out a 6 from the constants, and then let's look at the variables here, y to the 4th and y to the 3rd. The greatest common factors between variables with the same base is just going to be the same base with the lowest exponent, the smallest exponent. So between 3 and 4, it's going to be 3. So that's what we're factoring out. 6y cubed is going to be the greatest common factor between these two. And let's see what's left. So after we take out 6y cubed from the first term, we're left with 4 and then 4y. So a way to check this, if you multiply 4y times 6y cubed, you're going to get 24y to the 4th. And this stays as a subtraction because we left that in there. 54 divided by 6 is going to be 9 is what you're left with, and then y cubed divided by y cubed is 1, which we're not going to write in. So there is your factored form of that. Okay, so let's move on to a difference of squares. We've listed out the perfect squares here. So these are numbers that if you see these perfect squares in your terms that you're supposed to be factoring, it's a good indicator that you're probably going to be using this difference of squares factoring method. So the rule for factoring is if you have x squared, if you have a term, a perfect square, x squared, and your other term is a perfect square, y squared, it does have to have a subtraction here for this method to work. This will be equal to x plus y times x minus y. So you just take each of the square roots of each of those terms. You're either adding and subtracting them, and then you're multiplying those terms together. Pretty simple. Okay, so here you have a sum of cubes and a difference of cubes. So it does look slightly different for each of these. So if you have perfect cubes that are being added together, you're going to use this first one. If you have cubes, one cube that's being subtracted for another, then you're going to be using the second method. Okay, for the sum of cubes, if you have a term that looks like x cubed plus y cubed, so they're both perfect cubes, they're being added together, there's the bell, that is equal to the first term is x plus y, so you take the cubed root of those, add them together. And the second, you'll have a trinomial here, which will be x squared minus xy, which is important, plus y squared. Like I said, this is very, very similar to the difference of cubes method with just a couple sign changes. So in some places where it's negative, it'll be positive, or where it's positive, it'll be negative. Okay, so just make sure you keep track of that. And the rule for factoring a difference of cubes, like I said, very similar. If you have x cubed, now we're subtracting the other cubed, that is going to be equal to x minus y, and then your trinomial will be x squared plus xy plus y squared. Okay, so there's no way around it. You're going to have to memorize those. And then on our second page here, we'll have trinomials. So I'm not going to do any of these examples, but I'll give you a few reminders. This is the one where you're going to be splitting up like this. And these last two terms have to multiply together to get 30 and add together to get, multiply together to get negative 30 and add together to get negative 13. That one is probably the one you've had the most practice with. 4 terms here, just remember you're going to be grouping these. like this, and then you're gonna factor greatest common factor out of that, greatest common factor out of that, and then you should see some similarities where you can factor again. I'll do another video on that example if you have forgotten, and I'll do another video on one of these examples, because these ones are kind of tough. But I just want to highlight here this: always check for greatest common factor first. So important, okay? Because some of these won't work unless you factor out a greatest common factor. Okay, so if you have questions, send me an email, post on your Padlet, all that good stuff.